Hello, Caymans. Welcome back. Mr. Eicher here. This is the last part of our multi-part lesson for Chapter 15, Light, talking about volumes and areas of three-dimensional shapes. First question we have, what's the formula for volume of a pyramid? Mr. Brack has an empty pyramid, empty prism. The base of the pyramid is congruent to the base of the prism, and their heights are equal. So the volume of a pyramid, PY, volume of a pyramid, 1/3 the area of the base times height. The volume of a prism is the area of the base times height. How do these formulas compare? Well, since the bases are congruent, and the heights are congruent, the prism is 3 times the volume of the pyramid. You could also say the pyramid is 1/3 of the volume of the prism. After comparing the formulas, how many times will Mr. Brack need to fill the pyramid with water and pour it into the prism in order to completely fill the prism? So we would need, or Mr. Brack would need, 3 pyramids to fill up the prism. That only applies because they have the same dimensions, which is mentioned at the start of the problem. All right, and then number 2. Jane has a 20-gallon fish tank full of water. She needs to move from one room to the other. She pours out all the water. Hope she waters the garden with that. It's in a drought right now. The fish tank is a right rectangular prism. So rectangular prism, you get a rectangle like this. We have a rectangle like this. Connect some sides. Go like that. And it's a right rectangular, so it meets at a right angle. There's no oblique angles or anything like that. How do you find the volume of a right rectangular prism? Well, the volume would be the area of the base times height. Or you could just do the volume as length times width times height. Where cursive L there is just a length. Length times width times height. Given the dimensions, part B, given the dimensions of water inside the tank are 30 inches by 12 inches by 12 inches, what is the volume inside the fish tank in cubic inches? So the volume would just be multiply those, 30 times 12 times 12. And when we do that, we get cubic inches. 30 times 12 times 12 is 4320 cubic inches. The next question, though, is how would we convert this to cubic feet? So when we do that, we're going to have to say we have this many cubic inches. How many inches are in 1 foot? Well, 1 foot has 12 inches. Now that's not going to be enough though, because we need cubic inches. So we actually need 2 more sets of this conversion factor for a total of 3. So now we would have 4320 times 1/12, 4320 times the 12th, times the 12th again, 4320 times the 12th, times the 12th, finally third time times the 12th. This would be equal to 2.5 cubic feet. So that seems like a pretty big difference, right? Cubic inches versus cubic feet. And that cube looks really huge, so I'm going to redo that. There we go. So actually, we have 2.5 cubic feet. So anytime you're converting from cubic inches to cubic feet, you do need 3 of those conversion factors. And then part C, the fish tank weighs 225 pounds when it's filled with water. 1 cubic foot of water weighs 62.4 pounds. What's the weight of the fish tank when it's empty? So we just calculated the cubic feet. So we're told 1 cubic foot of water weighs 62.4 pounds. We just calculated that we have 2.5 cubic feet. And we're told 1 cubic foot is 62.4 pounds. Where should we put the pounds in our unit conversion? Where should we put cubic feet? Well, we want the cubic feet to cancel. So we have cubic feet, and then we want divided by 1 cubic foot in the denominator. That leaves 62.4 pounds, LPS, pounds in the numerator. So that means the water itself weighs 2.5 times 64. The water is 156 pounds. Water itself. We're told, though, in the question that when the fish tank is full, the weight's 225. So if we subtract the water, which is 156, 225 minus 156, and we get 69 pounds. This would be the weight of the empty fish tank. No fish, no water in it. This says round to the nearest pound, but it appears that there is no rounding that was necessary. So that was an example of doing some unit conversion, as well as using those formulas for volume of different shapes. Thanks for watching this video. I hope you have a great day. And please email your teachers if you have any questions.